This summer, I joined a team of researchers whose task has been to develop a tool that will describe the biaxial stress on a ferromagnetic material by using an eddy current probe. This project is being supported by Engie, a European energy company who is interested in using this technology to measure the stress on their steel natural gas pipelines. A magnetoelastic constitutive model was developed to describe the magnetic properties of ferromagnetic materials under stress. This is a multi-scale model. The reason we can use this technology is that ferromagnetic materials exhibit magnetomechanical behavior, which means that the magnetic properties of the material are affected by stresses on or within the material. We employ the finite element method to model the impedance measured by the eddy current probe using the magnetic permeability of our given material, which is described in our multi-scale model. This impedance is also affected by the distance the probe is from the material, the frequency of the applied alternating field, and many other factors that we can adjust to determine their effects. One of the materials that Engie will use for their pipelines is an alloy called X52 steel, and one of my tasks was to apply its material parameters to our multi-scale model. I also had to construct and evaluate two proposed stress identification methods. The first used image processing to obtain a map of impedance values measured in each stress state. This was done for 4 different orientations of the eddy current probe. After each orientation was measured, the 4 maps were superposed to give the likely area of stress configurations corresponding to a given measurement. The second method was very similar, except it excluded image processing, but searched for values which fell within a lower and upper bound described by an impedance value at a given stress configuration. An important consideration in this process was the delta measure, which took into account experimental and statistical error. There were also physical limitations to the robustness of this process. Some of the next steps for this research are to accurately characterize the material studied, as well as other materials that we need to test, begin retesting the method experimentally, and expand to more complicated stress configurations. Thanks to Dr. Yalosov, Dr. John in the University of Michigan, Dr. Laurent Daniel, Dr. Jan Lebehan and Laurent Santandrea, and the University of Paris Sud, and thanks to Dr. Rockwood and the whole Department of Physics at Morehouse College.